Okay, it's me again, and we are here to do hypothesis testing on means, the second part of the information in chapter 15. So just a reminder that a hypothesis test, essentially we are provided with a guess about the population. And if you recall, in the notes for hypothesis tests on proportions, we referred to the guess as something with a 0 as its subscript. And back in the beginning of chapter 15, we called it P sub 0 or P naught for proportions. So this is going to be mu naught. It's going to be our population mean. Okay, so we're provided with a guess about the population, mu naught. Actually, let's say this is the population mean. And we also have sample data to test against the guess, right? So we basically are being told something is true about the population, and our job is to say, no, it's not. We believe that this other value is actually true, this information from our sample data. So the way that this works is it's basically got 3 steps. First, we state the hypotheses. So the way this works is that our null hypothesis, which is H sub 0 or H naught, our null hypothesis, it represents that nothing has changed. Okay, so we would record this in these 3 potential forms. Our null is always the same. I don't know why I said our null would have different choices. Our null always says it's equal to, because this would represent no change. And this is a literal value, right? So we use the symbol mu, the equal sign, and then we stick a number where mu naught is for our null hypothesis. So this is the first step. And then our second step is to record our alternative hypothesis. Okay, which means that there has been a change, right? Change has happened. So the way that we will record this for means, we would say either mu is greater than mu naught, mu is less than mu naught, or we would say mu is just not the same, right? So our sample, the sample is larger, or the sample, my pen does not like me today, is smaller, or the sample changed, right? Like this third option doesn't really tell me a whole lot. It just says there has been some kind of a change. Then what we get to do is we go to our calculator. And just like when we had a confidence interval for means, we now, we now have a hypothesis test for means. So we're going to run a hypothesis test. And that's going to be in the calculator. So this will be a t-test. Remember that if this was a confidence interval for means, it would be a t-interval. So this will be a t-test. And we have the same 2 options that we normally did for a t-interval. We can either provide the calculator with data, or we can provide the calculator with stats. Okay? So the data would be, we put all values in list 1 and provide the mu naught value. Okay? The next thing that we give is the direction. So we actually tell our calculator which one of these symbols we are going to use. So we will, you can see that when we go to check a t-test on the examples in a moment. Now, the other example where we actually have to fill more information in is that we provide the calculator with stats. So this is very similar to when we had to do a confidence interval. That meant we needed the sample mean, the sample standard deviation, the sample size, and we also need the, in this case, the mu naught value, the guess for the mean, and we also need the direction. So we also need to select which direction we're going with our alternative hypothesis. And then I'm just going to jump to a new slide so I don't create too much confusion here. But we run the t-test, and the output is two things, okay? We get a t-score, and we get a p-value. Okay, so remember in the video for the hypothesis test for proportions, the p-value, this is a probability. And when I draw pictures of the results, it's also represented by the shaded region in the picture. So we shade in the same direction as our alternative hypothesis. So the p-value would be the shaded region beyond our sample statistic. And our t-score tells us how many, and a z-score tells me how many standard deviations I am away from the mean, but this is not standard deviations. So this tells us how many standard errors our sample data is from the mean. So people always ask me, like, do I need to talk about the t-score and the p-value? And the answer there is yes, absolutely. You need to mention both because they're both very important. Okay, now, step 3, once we have the information from the calculator, is to make our conclusion. Okay? So we have only 2 potential options here. So I'm going to go A's and B's. If my p-value is less than the provided alpha level or significance level, whatever language is given, then we make the conclusion that we reject our null hypothesis, and our conclusion is phrased with some language like, there is enough evidence to show, and then we try to rewrite the alternative in some way. Okay, so our second option is if we get our p-value and we compare it to the provided alpha level and we find out that it is in fact greater than or equal to the alpha or significance level. Okay, if this is the case, then we are not allowed to accept the null. What we actually do is fail to reject the null. And this means there is not enough evidence to show the change, or HA. So remember, we're always trying to show that something has changed. Our response will always be with respect to whether or not we can show that there was a difference here between the two. So keep trucking along here with my videos. I'm trying to make it just like class time, so go ahead and follow along next with some of my examples straight from the packet.